Hello everyone, this is Amika Mahajan. Welcome to my channel. This video is focused on objective and very short answer type questions from current electricity. First question, VI graph for a metallic wire at two different temperatures, T1 and T2 is as shown in the figure. You have to tell which of the two temperatures is higher and why. Now in VI graph, V is along y-axis and I is along x-axis. So slope will be perpendicular upon base. So it will be delta V upon delta I. And this will be equal to resistance. So slope will be representing resistance. And we know that slope is more, resistance is more. Here, wire with temperature T1 is having more slope as compared to wire with temperature T2. So resistance of wire at T1 will be more than that of at temperature T2, and we know that in case of metals, more temperature means more resistance. Therefore, T1 will be representing higher temperature. Plot a graph showing resistance of conducting wire as a function of its radius, keeping the length of the wire and temperature constant. We know that R equal to rho L upon A. We are keeping temperature and length constant, so resistivity and length will remain same. So R is inversely proportional to area of cross section, which is equal to pi R square. That means R is inversely proportional to square of radius. So it will be exponent graph. Resistance will decrease exponentially with radius. Two wires of equal length, one of copper and other of manganin, have the same resistance. Which wire is thicker? Because resistance is same. So rho of copper, L of copper upon A of copper will be equal to rho of manganin, L of manganin upon A of manganin. Because lengths are same, so these will cancel. And rho of copper into A of manganin will be equal to A of copper into rho of manganin. We know that manganin has more resistivity as compared to copper. If this quantity is more, then copper area will be less in case of copper as compared to manganin. So manganin will be thicker. Give an example of material each for which temperature coefficient of resistivity is positive. It is in case of metals or alloys. Because in this case, with increase in temperature, resistivity will increase. So alpha will be positive. An example will be copper or nichrome. With negative temperature coefficient of resistivity means resistivity decreases with increase in temperature, that is found in case of semiconductors. Show variation of resistivity of copper as a function of temperature in a graph. Copper is metal. So this graph will be like this. It will not be a straight line increasing, but it will be a curve graph, not starting from origin. Little bit higher. Next, plot a graph showing temperature dependence of resistivity for typical semiconductor. How is this behavior explained? In case of semiconductor, resistivity decreases with increase in temperature, and there is exponential decrease in temperature. Exponential decrease in resistivity with temperatures. Write the characteristics of manganene which make it suitable for making standard resistances. For standard resistance, resistivity should be high and low temperature coefficient of resistance should be there, and it is found in case of manganene. Next, define mobility of electron in a conductor. Mobility is defined by drift velocity divided by electric field. Now, how it changes when temperature of conductor is decreased? Mobility is drift velocity divided by electric field. So, drift velocity has formula E by m into tau. We are dividing with electric field, so capital E will cancel, and this will be the relation for mobility. Now, with decrease in temperature, in case of metallic conductors, relaxation time increases, so mobility will increase. Mobility is independent of potential difference. So when we double the potential difference, keeping temperature constant, there is no effect on mobility. For two nichrome wires connected in series with a battery, how does the ratio of drift velocity of electrons in them depend upon lengths and diameters? We know that drift velocity is given by this relation. In place of E, I can write V upon L and V equal to IR. What is R? Rho L upon A. When I put all this in this relation, what I get? Ultimately, I get EI rho tau upon MA. So when I have to compare with length, what we find, this drift velocity is independent of length. So for two wires, ratio of drift velocity will be 1 in terms of length, but it is inversely proportional to area of cross section. And area is pi d square by 4, where d is diameter. So drift velocity is inversely proportional to square of diameter. Therefore, drift velocity for two wires will be inversely proportional to their diameters. This will be the ratio. Next, a cell of EMF E and internal resistance R are connected across variable resistance R. Plot the graph showing variation of terminal voltage of the cell versus current I. E is IR plus IR. This R is IR is V. So what is V? V is E minus IR. With passage of time, internal resistance increases. So V will decrease. Hence, we will get decreasing graph, straight line, V versus I. When there is no current drawn from the cell, this V will be equal to EMF. Ultimately, this V will decrease with increase in I and reduce to 0. Thanks for watching this video. Like, share, subscribe my channel.